Hello everyone, and welcome to December's research seminar from the UCL CBT. This month we're taking part in Hard Fork Decentralized, a blockchain festival that's going on all over London. Check them out. You've got some wristbands, I think, that were handed out at the front. If you've taken one, you'll be able to go and see the other events. Before we start with today's event, I just wanted to talk a little bit about the UCL Center for Blockchain Technologies, where you're being hosted today. We are a center that sits at the middle of 8 different departments at UCL, which range all the way from the Energy Institute to Computer Science to the Bartlett School of Architecture. And we connect both UCL students, our researchers, with government institutions and industry members. We like to look at blockchain with this kind of framework, firstly from legal and regulatory perspectives, from technical perspectives, and from business perspectives. And we like to think of ourselves sitting in the middle. Because we have such a wide-ranging network of academics at UCL and industry practitioners who help us out, we're able to draw from all of these different areas and present a holistic view of the ecosystem. Currently, we've got about 130 research fellows who are investigating all of these different research areas. Roughly about a third of them come from UCL, and out of the other 2/3, a third of those are academics from other institutions, academic institutions, and another third are industry fellows and actual government bodies or other corporations. These are an example of some of the people we've engaged with. A lot of them are financial, since we have more of a specialty in sort of the fintech area, but all sorts from, the ECB to the Federal Reserve to the Bank of England and the UK government. Some of the exciting things we have planned for next year include sort of some of these areas. So the first is education. We're providing executive education courses for those who are interested in learning more about blockchain in a deeper manner. Our research seminar series, so at the moment we're looking to be putting on at least 2 events a month. One, this type of event where you'll see some presentations, have a discussion, but also standalone discussion groups. So we're launching a discussion group series where we'll be taking a project or an area and having an academic lead or an industry lead discuss it with the audience. We're also organizing conferences, so the next one that's coming up is our annual P2P conference, which centers around digital currencies. We're lucky that that's going to be hosted at the ECB. And we're building out our own blockchain research function. So the flagship project we have is something called BARAC, which is Blockchains for Algorithmic Regulation and Compliance, largest government-funded project to investigate RegTech, essentially. We're building out our own in-house research team. If anyone's interested in being a part of that. We're going to be running and setting up our own blockchain labs, so focusing on technical research. And 3 new things that are coming up. One is we're setting up working groups with joint academic and industry leads to investigate some of the areas that we're working on. We're also in the phase of looking at setting up an acceleration program for startups, because we get so many coming our way, but we're looking at how we can more formally help them incorporate into the DLT system. So these are the 4 of us who are at the sort of running the center. I'm Nikhil Vagdama, so I'm the deputy director. Thamin's up next to tell you a little bit more about today's event. And most importantly, if you want to stay in touch with us and you want to come to our events and get updated, please go and sign up to our newsletter. Otherwise, we're not going to be able to email you with all these lovely bits and pieces that we're up to. So that's all from me, and I'm going to pass it over to Thamin.
Hi all, welcome to today's session on decentralized finance, and I just want to give a quick bit of context on what some of these terms mean in terms of specifically decentralized and finance. Just before we get started, what's I just want to engage the crowd. What's very unique about this specimen here? Do throw out, just shout out sort of answers, responses rather. What's unique about it?
Serial number.
The serial number, yes. And what else is? How is that serial number sort of unique? What does that kind of reference? Yeah, banknote, yes. And can I just write £10 on another piece of paper and give it to you? No, why not? Special paper, okay. I can write on special paper as well. It's not universal, why not? Lack of trust. Okay, but what makes this unique to Yes, exactly. So we can see it's issued by someone, say a central authority here, sort of Bank of England, and we can look it up. And that is kind of a little bit just food for thought, I guess. And then we kind of consider some of the risks behind centralization. This isn't specifically referencing to sort of currencies at all, but more broadly around some challenges. So censoring of banning of users of system. I don't know if anybody's here ever been banned from a banking service provider or an online service, but it's not a good experience. Let me tell you from first-hand experience. There are organizations when they gain a monopoly, they may sort of have rent-seeking sort of features of their platforms. And then sort of organizations changing the rules of the system. I think what comes to mind here is these sort of platform businesses, a bit like Uber. I didn't realize, but when I sort of scratched through and did a bit of research, an Uber journey is almost 60% subsidized by its investors. So one imagines when Uber takes over and monopolizes the ride-sharing space, they may want to sort of increase their fees in order for their stakeholders to be rewarded again. And then sort of organizations may start off honest, but there could be tampering of data further down the line. There could be hacks. We've seen, I think as recently I got an email from one of, I think it's Starwood group of hotels. 500 million accounts of this hotel were hacked. So there are some sort of security flaws in these sort of systems. And I don't really like references, but this gives a good sort of visual sort of representation of what we mean by centralized and decentralized and distributed. What's unique about the centralized system here on the right-hand side? Single point of failure, yep. But what are some of the pros behind this? Why don't you just shout out? Easy? Easy record keeping to an extent, yes? Speed, yeah, it's very fast. You know where the central point of authority or decision making lies. And as we move towards a decentralized system, something to think about here might be a railway system where you have a national sort of rail body, and then you have like sort of regional train stations and sort of local train stations. And then on the far sort of left, we have the distributed network. What's different here? Compared to the centralized system. So there is no single point of failure. So if one node was to sort of go out, the whole network would continue to exist. But what could be some of the flaws behind this kind of model? Complexity, yes. Do you think it'd be very quick if we're going to go from the far sort of bottom left to the top right node? If we're going to sort of travel through the network, will it take a long time? Yes, you can imagine it's much slower than a centralized system. However, we can see from the structure of the network that it's very robust and strong. And this kind of takes us to sort of thinking about distributed ledgers, where we have a centralized ledger where if we trust a central body. Let's just say in the instance of a clearinghouse, there is only one place where that record is stored. Now, in an instance where we may not have trust within a central kind of clearinghouse, it becomes a problem in sort of trusting the transactions that take place. And this is where the notion of a distributed ledger comes from, where everybody belonging to that node has a copy of that ledger. So that's something very important to kind of have at the back of your minds. So that means if I belong to a node and I wanted to query an account, I could do so, as I also have a copy of all the transactions taking place on that network. Now coming back to the elements of risk of centralization to the point of our discussions. So when we look at the banking system, on the outer areas, we have consumers, ourselves, with bank accounts. Then we have the banks itself, and then sort of within internally between bank to bank, there's a lot of intermediary transactions taking place. Now looking at in terms of the use case of central banks, it's quite a complicated procedure that sort of takes place, and we'll be exploring one or two of these areas in our discussions. When we just look at just taxonomies, I think the way to kind of classify these things is sort of between open networks and closed networks. On the open side, we have permissionless systems, and in sort of more closed systems, which is sort of looking at enterprise-grade solutions, we have we have sort of B2B organizations that have near arm length relationships. So I've just put on here. So on the permissionless side, we've got the crypto world, the crypto asset world, where you have public ledgers. You can query them. On the permission side, you've got private consortiums of organizations where the people or the nodes on the system, they have to be known, which means there's trust built within the system. There are lots of sort of applications happening in the financial services world, where we're seeing a lot of activities primarily within sort of capital markets. There's a report here, maybe many of you have seen, by Accenture. So Accenture sort of laid out the operations of the investment banks, and they kind of found out in these areas, highlighted predominantly in purple, where blockchain technologies could, or distributed ledger technologies could help these organizations save, I think it was 8 banks, up to $8 billion. Now moving on to our discussions, I like to refer to this money flower diagram, which was sort of brought up by 2 sort of economists from the BIS. And on the left, we have sort of widely accessible sort of currencies, and as we move there to the opposite side, we have some of these digital assets, or the cryptocurrencies that are emerging. And when we begin to map these out, it shows a very interesting sort of diagram. So we have sort of our currencies at the moment, sort of paper money, and then we're beginning to move towards sort of digital currencies or electronic form of fiat currencies. And then we can map out how within central banks, there's between central banks and the banking system, there's electronic sort of transfers taking place. And then sort of when we begin to map out the emergence of digital currencies and digital assets, it starts to portray an interesting image. So I'd be quite keen throughout this discussion to kind of talk about some of these points and listen to some of our speakers. So we're going to just I'd like to sort of welcome today's speakers. We have Julian Wilson, or Julian rather, just from Barclays Group, who will be talking to us around sort of tokenization of fiat currencies and notarization. Sid, who's from Token Analyst, will be giving quite a meaningful insight into some of the analytics behind the sort of crypto assets world. And Rushir, who will be from Deloitte, who will be talking more broadly around tokenization of assets. So with no further ado, can I just, Rushir, we'll get started with yourself. Sorry, so we get started with Julian. Apologies. And yeah. Mic's up.
Yeah, does it clip on, does it?
Yeah, clip on you.
You take that down. Thank you, Thami. Hello, everyone. Thank you. Welcome to the invitation. And it's great. So what I was asked to do is share with you the experiences that my team and I had when we first looked at the building blocks of cryptocurrency working in a bank. I want to stress that nothing I say constitutes a product, strategy, or announcement. Okay, it's just me sharing and learning along with you guys in the spirit of openness that we all now increasingly try to adopt. At heart, I'm a product guy. My background's 10 years at Apple, working in advanced technology, a few years with AT&T, where literally 20 years ago this month, we demonstrated anonymous cash on a SIM card, working over mobile phone networks using Nokia's and a modified Newton, which was the forerunner to the iPhone. Literally 20 years ago, predicting there'd be a market for downloading music and paying for it efficiently, 9 years before we had an iPhone. And then a few years, a couple of my own startups, and then at Barclays. I joined the engineering team 5 years ago at Barclays. And of course, one of the most important developments in the field of computer science was brought to us just over 10 years ago when Satoshi published the paper describing a mechanism for censorship-resistant payment. But there's a couple of things I'll come on to in terminology. All I hope to achieve in this 10-minute session is give you a high-level view of how I took the approach and maybe some of the key principles to get right at the beginning. Because if you make a small degree of error at the beginning of understanding, it can end up in a huge mistake further down the line. So there's two things you need to understand as a product guy. One is the business. How do the pieces fit together? How do you make money? Why do people give you money? If you deliver your service through other people, through third parties, how do they make money? And what function do they play? What systems do they need? How do they connect to yours? You need to understand the business you're working in at a fundamental level. And the first lesson from me in terms of looking at the crypto building blocks was, we haven't built a means for me to pay you today. What we, the banks, have built over the last 6 or 7 decades is a mechanism of liability transfer, a means for my bank to transfer a liability to yours. And when you introduce the concept of different currencies and different banks, then that gets even more complex, because you've got purchase of currency, agreement of rates, settlement, and a host of other systems. So the first one is understanding where the problems lie. The second one is the technology. You need to distill the essence of what it is that you've been introduced to. Not just understand what the acronyms mean, distill it to its essence. And the first time I looked at them, I was working with a lovely, bright colleague of mine, who was the co-inventor of everything we did. We published a few patents on this based in 2014. The first thing I did was I said, we've been here before. And he laughed, because I knew he knew what I meant. And I went over to our National Archives Centre in Wythenshawe, and I asked the curator to bring out some artifacts of the way we used to do things. This is what's called a signature book. And you can't read it, but there's an entry there. Anne Ogle, 5 feet, long white hair, missing front teeth, heavily stooped, and a thickish moustache. This was an 18th century goat-bound book. But we had to have mechanisms for identifying people before we gave them the money or the things that were theirs. And that's what we used to do in a world before we had open networks. The thing in the middle is a thing called a bearer instrument. I promise to pay the bearer on demand. Not I promise to ask them for a utility bill, a passport, proof of residence, a host of other stuff. I promise to pay the bearer on demand. The third thing was a fully loaded revolver, which up until 1928 was standard issue on a bank manager's desk in Barclays. It's got absolutely nothing to do with cryptocurrency or this discussion, really, but I'm just in awe of the personal responsibility that previous generations had in going about their tasks, compared to today's health and safety, political correctness obsessed world. Anyway, the point is that what we did in those days was we put the individual in charge of being able to assert something they owned or had proven or had earned. That's what we did. And that, to me, is the essence of what the building blocks of cryptocurrency do. They enable us to rethink the foundations of the way in our business we do things. You can simplistically distill the building blocks in these 4 categories, I think. Blockchain has become synonymous with building blocks of crypto, but I think that's a misnomer. So let's get this first thing right. It's become synonymous, but what's worrying is the specific implementation of the blockchain, which supports the ideological goal of Bitcoin, the currency, is what people understand. However, what it is an immutable ledger. And as was hinted at in Thamin's slides, that's infinitely configurable, from completely open and ideologically pure, like the public blockchain, to a permissioned ledger, where you can define who can join that network, who can write to that database. And that's a function of the consensus mechanism. And consensus at one level could, of course, simply be prescriptive. You know, we can have a centralized implementation of the other 3 building blocks if we want to. Cryptography, to me, is critical, and it's the key, and arguably it's the most important component. Because what cryptography does is, once again, distilling it to its essence, it allows us to meet 2 simple things. It not only secures information at rest and in transport, what it does is manage permissions. One of the fundamental tenets of a bank's relationship with its customers is only we and you can see those transactions. So a starting point for us from a design point of view is we need to replicate that. You can't have a situation where you can download an app and once you've inferred one transaction from one wallet holder, you'll be able to effectively work out where all the transactions have been. So cryptography is critical. It enables you to manage permissions on an open network and also, through that, meet regulatory obligations. Propagation is how everyone knows what's happened. And the use of propagation is also a function of the consensus mechanism. So I wanted to, the brief I was given as well was to look at those conditions where these building blocks might be applicable to businesses. So there are various, if you like, criteria when perhaps taking a crypto building block approach probably makes sense. And those are situations where multiple parties rely on the same data and that data being accurate. A situation where verification or validation is needed at the point of a transaction. A third criteria might be where multiple parties who aren't necessarily you are required to contribute to the maintaining of that data. And the third, and finally, of course, there just simply might be too many people to feed from the funds that are available. But the design can, as was hinted at by Thamin as well, you can have on the left, public, which is what I would call like Ethereum and Bitcoin cryptocurrency today, where they are permissionless networks designed for a world where it ought to be resilient in a situation where there is no trust between parties. Right over to the right-hand side, where you may have multiple parties, but they're all part of your business community and network. Now, in that world, and the private world, it's hard to imagine a situation where you're building a network for people that don't trust each other. Because if what you're doing is re-engineering your value chain, your suppliers and your customers, it's highly likely that they do trust each other. And so you may prioritize that performance and control above the ideologically pure, pure openness. Because the ideologically pure comes with a heavy price. You know, it's reasonable to describe the consensus mechanism as an economic disincentive to commit fraud on an open network between people who don't trust each other. And there's a price for that. And that's performance and cost. So there are a variety of ways you can configure these building blocks, and the way you configure them is going to be a function of how you envisage the business and the problem you're trying to solve. I want to say one more thing, which is I've mentioned the concept of fiat currency. What I didn't mention was the other use, which was this same model. So I was talking, so when we designed what we designed, we wanted to tokenize funds. Then this plays quite well to the note analogy that Thamin just put up a minute ago. What I saw was, today if you look at Apple Pay and Google Pay, they have tokenized a payment instrument. And it's a superficial enhancement. It improves consumer engagement in lots of situations, but it doesn't change anything underneath. The foundations are exactly the same. You're still plugging into the bank networks and the liability transfer mechanisms and the associated costs of doing that. But if you tokenize a number, a piece of, if you like, that's recognizable in a balance sheet, then you can cut that middle layer out. So it's about re-engineering of the foundations and enable someone to say, here's £11.75. I've taken it off my balance, it's now transferred to you. If we're both in the same bank, the bank's sterling deposits look the same. All that's happened is we've swapped the label from one person to another. But you can use that same principle to notarize a data asset. Identity. I ought to be able to do the same thing to say, I'm Julian, I live here, I was born on that date. But you could also apply the same principle to notarization of stuff you've earned. My credit reputation, my value, my behavioral attributes. And I think this is where these building blocks have a phenomenal opportunity in helping us all, as citizens, start to redress the balance, or the imbalance, if you like, between how our data is used and monetized. We all give it away today. We do so willingly because we value the social media networks and Google and the other things. But legislation through GDPR and public opinion is wanting to redress that balance. And these building blocks offer a perfect opportunity to do that. They let us take control of it and, most importantly, manage permissions. We decide. We can quite easily decide who can look at and read something. I can have the public key in my secure element of my smartphone, and I can say which entity can look at it and not, and for how long. So, I hope that's given you some food for thought. We're going to have a quick talk. Thank you very much for your attention, and I look forward to answering any questions when we have the panel thing. Okay? Oh, sorry, I've got it.
All right, so yeah, I just wanted to talk to you guys a little bit about this whole notion of decentralization, but from a more data-driven perspective. And so, as the previous speakers were talking about, the whole notion of public blockchains, especially as they're prevalent today, relies on the concept of people that are participants in this network taking comfort in the fact that everyone else has a copy of the ledger, of the distributed ledger, right? And so, our kind of motive to start Token Analyst, which is we're a London-based startup, was essentially questioning this notion. Just because everyone else has a copy of the ledger doesn't mean that it's necessarily decentralized or trustworthy or necessarily even secure. Why is this? Because the blockchain essentially is just a database, right? It's just an open database that people can access, and it holds the transactions of everyone that has transacted in the crypto assets that are built on top of it. And this database is pretty interesting because it's for all intents and purposes, it's pretty undecipherable for the average human being to really go into the ledger and figure out what's actually going on. And so that's kind of what inspired us to start Token Analyst. Essentially what we view this whole industry as is kind of we're just reaching the tip of the iceberg, so to speak. It's a very new space. Not a lot of people really even understand what's going on the ledger itself, especially on these public ledgers. There's a lot of theory and kind of thought experiments going on in the space in terms of how this could change society. But we feel that to really drive change effectively, there needs to be a real certainty into the actual utility of these crypto assets and what's really going on the blockchain itself. And so the majority of the attention in the space today is on things like price, things like social sentiment, Twitter mentions, so on and so forth. And very little attention is being paid to, who's actually using these crypto assets that are on the blockchain and what are they being used for. So one of the big questions we decided to tackle first is, can we figure out or can we decipher who are the parties that are actually transacting on the blockchain itself? And so when we view the blockchain as a database, at the top are basically the raw data that appear on the ledger. They're just cryptographic hashes, pretty much anonymized, where you only see a transaction value between two anonymous cryptographic hash addresses or user accounts. And so what we tried to do is essentially take these hashes and analyze them in a way such that we can somehow get to a stage where we can identify what types of entities these hashes represent. So it's a pretty challenging technical problem to address. And so, we started by really taking a deep dive into the Ethereum blockchain. It's one of the biggest blockchains, public blockchains out there today. And taking a list of all the addresses or cryptographic hashes of the user accounts on the blockchain. It's over 40 million hashes right now today. And really taking a hard look at the raw data and the features that we had available to analyze these addresses. So some of these features include, how often does this address transact with other addresses? What is the similarity of addresses that it transacts with? Does it usually transact with the same address time and time again? What is the volume of crypto assets that it transacts with? Is it in the millions or is it one or two every single time? And so taking all of these factors into consideration, we essentially arrived at a system to classify addresses on the blockchain. And so what this really allows us to do is to get to a situation like this where given a token network, this is just an example token, it's a ERC20 token on the Ethereum blockchain, one of the many crypto assets that raised several hundred million in a token offering over the past couple of years, and essentially see who are the participants in this token economy, and analyze it to an extent where we can really trust and know what's really going on in this distributed ledger that's in everyone's hands, right? And so in the visualization, essentially each of the colors of the nodes represents a different classification that our algorithm has given to each of these addresses. And each of the nodes are actually individual addresses that own this particular token. So starting from the center, the pink nodes in the middle are actually members of the token team themselves, the people that issued the token in the first place, the developers who wrote the smart contracts to generate this token on the blockchain. And then you can really see the relationships to the green addresses in the bottom, who are the early pre-sale investors. So before this token was even offered to the public, these large, usually accredited investors got access to this token before the public got access to it. And we could see those transactions happening on the ledger in real time. And so this is really illuminating. And then finally, over on the edge here with the light blue and the blue nodes, we also see kind of the token being propagated to exchanges, crypto exchanges, public crypto exchanges like Coinbase, Binance, Bittrex, and then how these exchanges manage these tokens internally within their cold storage addresses, which are, seldom touched. They're kind of kept away from the public internet for safety. And then they're hot addresses where they frequently transact with user funds. So, the hot addresses are this light red over here, and the cold storage network is the light blue and the dark blue nodes over there. You can see the dark blue is really kept separate from the rest of the cluster, purely because the transactional frequency is very less, and there's several layers of separation before you can even get to a cold storage address, just for security's sake. But the fascinating thing about all of this is this can be viewed on the ledger itself. It can be viewed at the transactions that are happening between these addresses. And it's something that a lot of people, just by looking at the ledger, can't really decipher because, as I said, it's just anonymized hashes transacting. And so, essentially what we're trying to build here is just kind of mapping of different entities and what kind of features do they exhibit most often. By features includes, the volume of sent transactions, the volume of received transactions, and then, how close are they to each other in terms of their behavioral patterns on chain. So we've developed, kind of a good statistical model to really get at this. And then some of the most interesting things from this actually are, if we propagate that model onwards, we see a lot of transactions being submitted or propagated, as you were saying, to the chain to be included in blocks, basically. And some of these transactions don't get accepted in blocks because people don't pay enough fees for the miners to include them in blocks. What we're essentially able to do is to have this notion of predictive consensus and predict which transactions will be included in blocks in the future. What this means is, when a transaction from an exchange to a user is about to be accepted into a block, this actually relates to real-time exchange order books and how the price of the cryptocurrency will move in the future. And that's kind of where our business kind of lies, is in kind of predicting future volatility and spikes and shocks to crypto asset prices. As I was saying, the kind of statistical modeling that we do really allows us to categorize these different entities, these different parties, and really put a kind of a picture to paint, what type of behavioral imprint they leave on chain. And so some of these things are really interesting to note, and they're constantly changing. Behavioral patterns change. They change up their internal algorithms. Users change. The market crashes. Different behaviors emerge. So it's really fascinating to keep on track of. And essentially, what we're leading to is from kind of this anonymized hashes that is what is the distributed ledger today, to a more decipherable, human-readable list of transactions between entities that are known and that we can actually take faith in and take comfort in and know that, all is still well with the world. My money's not really being taken by some anonymous entity somewhere in the world when I transact with this address on the chain. And so that's kind of where we're moving towards. And we're getting to this pretty quickly. And one of the points I wanted to make is a slightly technical picture, but we were doing this last week where the nodes, the blockchain nodes that are basically hosting the ledger for all these public blockchains all over the world. There's around like 17,000 nodes in Ethereum and another 10K for Bitcoin. These nodes are actually open source pieces of software. So developers all over the world contribute code to these nodes to develop and improve them over time. And one of the fascinating things we've found is that these nodes are actually really imperfect. They don't really follow the rules of the protocol as it was laid out in the white paper or the yellow paper by the Satoshis of the world. They're really human interpretations of those white papers. And so the human interpretation then turns it into code, which is oftentimes imperfect. So we've seen many inconsistencies between node implementations, where one version of the ledger in a certain node is different than another version of a ledger in another node. And it's kind of alarming because most people just take these nodes as reality, as fact, and say, you know what, I trust the nodes, I'm running a node, it's a distributed ledger, all good, right? When in reality, all these different lines are areas of inconsistencies we've found while compressing and analyzing a popular Ethereum node called Parity. And the other point to note here is, even to run a node today, it's a tremendous cost. Like an average person, for us, we're running several nodes, and for some of the full nodes, which really validate the state of the blockchain at every point in history, it costs several thousand to run per month on a huge server, cloud server instance. And so it's really impossible to run on your computer today because it requires a SSD drive of over 2 terabytes, with a high I/O throughput. It's just really just not feasible to run these nodes. So that calls into question again this notion of decentralization and trust in the ledger that is held by everyone else. Who is exactly running these nodes? It's usually larger companies who can then go into these ledgers, tamper with the data, and then propagate that data to other nodes. So it's just something to keep in mind, as you kind of explore this space. Yeah, and so about us a little bit, we're essentially running nodes for multiple blockchains all over the world. We have it deployed in multiple countries all over the world so that we get transactions in real time as soon as possible, as soon as they're mined, and sometimes even before they're mined. And essentially, you can call our API today to get these transactions in your computer without running a node yourself in real time for free. And you can check out docs.tokenanalyst.io to have a look. And also check out our website. So we have a publicly accessible website and a Slack bot and a Telegram bot that you can subscribe to, where you can see some of these interesting transactions between interesting entities on-chain and really have a look into what's going on the ledger itself. Cool. Thanks.
Thank you very much. Last but not least,
Well, for me, just bringing up the video. My name is Vagdama. I've been with Deloitte's blockchain studio here in the UK for around about 3 years now. We've had a blockchain studio in the UK for slightly longer than that. Yeah, and I'm going to talk to you about real world assets. But before I do, I wanted to show a video that I've been showing a lot. One of my favourite videos.
if we can get some audio going.
A group in the 90s discussing on NBC or something, discussing what the internet is.
Back 56 past, I wasn't prepared to translate that, because I was doing that little tease. That little mark with the A and then the ring around it. See, that's what I said. Katie said she thought it was about.
Yeah. Oh.
But I've never heard it. I've never heard it said. I'd always seen the mark, but never heard it said. And then it sounded stupid when I said it. Violence at NBC.
Yeah, I heard it around big fat in the Western News.
See, there it is. Violence at NBC. GE.com. I mean,
Well, Allison should know.
what is
the
internet anyway?
Internet is that massive computer network. The one that's becoming really big now.
What do you mean? That's big. How does one? What do you write to it like mail?
No, a lot of people use it and communicate. I guess they can communicate with NBC writers and producers. Allison, can you explain what internet is?
No, she can't say anything in 10 seconds or less.
Allison will be in the studio shortly.
What is it?
What does it mean?
Oh, I thought you were going to tell us what this was.
It's
So
like
you
a
look in the
computer
dictionary.
billboard.
It's not an it's billboard, but it's
Right.
nationwide. It's several universities.
Right.
And others can access it.
Right.
And it's getting bigger and bigger.
It
Just
came
right.
in really handy during the quake. A lot of people, that's how they were communicating out to tell family and loved ones they were okay because all the phone lines were down.
I was telling Katie about
But you don't need that. You don't need a phone line to operate internet. No.
So, great video there. But the reason I like to show it is it's a nice metaphor for where kind of
Americans own
token applications and the blockchain more broadly are today in terms of kind of public understanding. So, everyone's heard of it, everyone knows about it, but not everyone is quite sure what it is. And more importantly, I think it underpins it. In the 90s, no one could have fathomed what the internet was going to become or what applications it was actually going to be used for today. I feel that we're in a similar spot with token applications, and there are lots of potential visions, and there's a lot of speculation as to how these tokens could be used. But yeah, I think it's still speculation at this point. So if we do look at some of those visions, though, it's really interesting to look at tokenized assets. And when I talk about tokenized assets, I'm going to refer to kind of real-world value being represented on a digital, in a digital form with transactions recorded on the blockchain. So that could be physical assets such as gold. It could also be intangible assets such as IP. There are some more interesting examples of previously unused commodities being tokenized, such as airtime. And I'll talk about that in a little bit. But, you know, it's not too hard to see a future where my liquidity is only limited by what I own, which is, you know, all of my property, everything that I own can be divisible, tokenized, and used for payment or for exchange. Go to a shop, and I don't want to pay with pounds. Maybe I want to pay with gold. Weird. But I can do that. A retailer can accept that payment as though they're accepting any other currency. And so I think that's a really, really powerful idea. But if we step back and come back to, you know, where these markets are today, I think there's another short kind of animation I want to show. Yeah, but it shows the token markets over the last, let's say, few years. You know, you can see how the space has changed, and obviously these are not just tokenized assets. These are a whole range of other tokens. But you're seeing a few bubbles emerge around Ethereum. Still very small. You've already seen the ending, but good to see, you know, fairly quiet, not much going on, a few bubbles emerging, fairly small scale as well. As we start to get towards 2016, we see some slightly more interesting projects emerging. The DAO, hopefully a few people here have heard of the DAO. It was a very controversial project, didn't do so well. But, you know, towards the end of last year and the start of this year, you can see it just explodes. And look at the value of some of these launches as well. They're not as small as you know, the 13 million, 12 million ones that were a few years ago. And so that's where we are today, or a few months ago. I think that's pretty cool. But, you know, what does that actually mean? There's some you know, interesting development in this space that does point towards this future kind of model of complete liquidity. And I think the more interesting cases that I've seen recently are in the spaces of commodities, energy, so, you know, tokenized energy, the ability to not only trade generated energy with a captive market, so the grid, but the ability to transact with anyone. I have energy, I'm generating energy through my house, through my solar panels, or I have surplus energy, and I want to sell that to someone who needs energy. That doesn't necessarily have to be the grid. So I'm creating this new market which is accessible by a much wider range of actors. And you know, that's also coming out in areas such as property as well. So again, a really interesting space where you're seeing, you know, these fixed assets suddenly starting to become divisible and tokenized. So I can sell small portions of ownership to a property or a block of flats. Recently, I think it was in August, a large development in the US, around $30 million, has just been tokenized. It's not entirely clear what they're going to do with it once it's tokenized. The assumption is that they will start to use that to generate additional capital. But the point is that you can start to attract new forms of capital for development, for investment. So you know, that's a pretty powerful concept when you think of how you can apply this technology. And the other interesting development in this space, I think, is the hardware or supporting infrastructure that's being built up around this. So in the studio in London, we've recently gotten our hands on a piece of kit called the Pundi X. Has anyone heard of it? Okay, so it's essentially a merchant terminal that allows a retailer to set prices for goods in their preferred fiat currency, pounds or dollars or whatever, and for a consumer to pay in their choice of currency, whether that's crypto, another digital token, fiat. They can pick which currency they want to pay in, and the terminal is connected to an exchange in real time. So the retailer receives what currency they listed the price in, pounds, for example. The consumer has the ability to pay using any sort of tokenized asset that's supported by the terminal or the exchange. And they're developing out a more interesting concept of starting to think about other assets that can be commoditized. So I mentioned airtime. And so PundiX are looking at commoditizing airtime, so creating digital tokens around your mobile contract, your data, etc., and allowing you to sell that on an open marketplace. And more interestingly, sell that in against some of these terminals. It does sound slightly implausible that I'm going to be able to, pay for a coffee using 100 minutes, but it just kind of underpins how this market is developing, how there's this sort of broad range of different currencies that are, or representations of value in the token space that are emerging. But I think there are quite a few challenges. That's why we're not paying for, other than kind of how impractical it is, that's why we're not paying for coffee using minutes or gold or anything. But it's also, I think, the main challenge for me is the lack of kind of legal or regulatory oversight in this space. It's all good and well having a token that represents gold, but unless a legal authority approves that that is proof of ownership of that unit of gold, it's not much value, because tomorrow someone else can sell that physical real-world asset, and unless I can enforce my ownership of it, it's meaningless. And the other point is this whole element of, and I'm sure we'll talk about it later, but the element of regulation and standards. So again, there's a lack of regulatory clarity in terms of how these tokens are governed, how they're listed, who has the right to buy them, who has the right to list them, how they're taxed. And so until regulators issue more clear guidelines, this market is full of snake oil traders, and there is a high risk for consumers, which is deterring investment, deterring kind of larger adoption. So, but we are starting to see that space change. So hopefully in the next few years, we'll see some very interesting development, from regulators, but also on the kind of infrastructure technology side. Thanks.
Lovely, thank you very much. Seems like the three speakers on stage. We'll go into a bit of a panel discussion. I'm just keeping hold of this. Lovely, thank you very much for that, for those presentations. I'm going to be caution on time, I'll dive straight in. So if anybody wants to sort of go ahead and tweet any of the speakers, please feel free, and if you want to follow up with questions, that's probably the best way to go about it as well. Julian, first of all, just when we look at sort of tokenizing fiat currencies, do you mind just speaking sort of a little bit on that topic? What would be some of the implications in terms of the banking world? How would that impact the relationship with central banks? And how would you, in your perspective, would you foresee that sort of taking shape?
Okay, it's big questions and a few all mixed up together. So. First of all, let's get a few things straight. In the UK economy today, central banks issue about 3% of the currency in circulation, which means that 97% of the currency in circulation comes from the retail banks. The amount of currency, when someone gives you a loan, that's the equivalent of issuing money. When someone gives you a credit card with a facility on it, that's the equivalent. So, first of all, to solve this problem longer term, will require some of the things we've said, which is agreement on a lot of complex regulation and maybe changes in rules. So let's park that for a minute, and now let's come back to the thing I was talking about, which is if a single bank was to say, can we use these building blocks to improve the way we do things today, that's much more feasible in the short term. Because what you would then be doing is coming back to what I was hinting at. If you use one of these tokens, to represent a number in a database, and you enable the real-time transfer of that token between two smartphone-enabled devices, you could not only affect the immediate transfer of funds within a currency quite relatively easily, you could, as long as you've got a few other things in place, you could do that internationally. In other words, if I've got a real-time exchange rate, and if I've got deposits in, let's say, sterling and rupee, and let's say I've already got a public interface to an ATM network in India, and I've got a mechanism for accepting cash in sterling, then I could say, I want to send £100 to my auntie in Mumbai. What's the rate, real-time exchange rate? It's 90 to 1. Okay, let's create an atomic transaction. Let's destroy 100 sterling. Let's mint 9,000 rupee. Transfer the rupee to me. I send it to my auntie in Mumbai. She goes to the ATM and takes the money out of the wall. That's possible today. And that would get rid of 15 or 16 of the current systems in use when transferring money through correspondent banking. But more importantly, it would solve a whole load of problems in the remittance market. You know, it costs too much and takes too long, and it's less transparent than it should be. And it's not that we don't want to solve those problems, it's just that doing so requires a lot of agreement. Does that answer your question?
Yes, it does. I've got a few follow-on, but I'll come back to that. I want to sort of head over to Rishi here. You've sort of you've worked on a couple of different sort of proof of concepts in this space. What have been the core challenges in the permission side of business models in sort of financial services? Has it been, yeah, I'll leave that open to you, and then I can draw in some of these points.
Sure. So I mean, look, it is something that we face with clients. It's generally an uphill struggle in terms of convincing them of the value of using a permissionless piece of infrastructure, and they have very legitimate concerns about it. So our approach does tend to be to look at public ledgers unless there is a clear case or clear need for a private or permissioned ledger. The challenges with private or permission ledgers, again, I think it comes around to getting the right people around the table. You need to create that minimum ecosystem to create value in a permissioned or closed off environment. And again, getting the right people around the table and getting them to agree on what that ecosystem looks like. What are the standards that govern it? Who are the authorities that govern it, if any? Generally, there are authorities. That's a very clear starting point for many of these clients. But yeah, I think most of the issues tend to stem in terms of getting that consortium effect or agreement.
And I guess just to follow up from that, what I'm sort of what you're kind of hinting, I guess, is from an implementation perspective, everybody, or the general sort of feeling is looking towards permissionless technologies and the benefits they're bringing, and sort of bringing them into a permissioned environment.
Yeah, look, I think that there are. My honest view is I think that the value that you gain from some of these more public or open ecosystems start to dwindle when you close off the environment. The whole opportunity around greater liquidity, openness, greater access, the ability to create single records across industries, those are all benefits of broader or wider ecosystems. The more you close off those environments, the less those become the less significant they become. I think also we mentioned security and the effect of kind of a decentralized or distributed network. Again, a smaller group of actors. I think you mentioned this to me. Is it's much more vulnerable as a network. Having said that, there are a lot of good use cases for permissioned ledgers where there is a genuine need for more control. A lot of them do stem around.
Do you want to just touch on one or two?
Yeah, sure. So we work quite a bit with a startup called Settle, which is it's a startup that looks at real-time clearing and settlement using their own proprietary ledger, and they have worked with a number of regulators who want access to the space, but also want to kind of assure regulatory compliance and the certain level of standards that are enforced among all of the actors in the ecosystem. And so to be able to do that, they want to set rigorous kind of entry criteria for any actor in the environment. So Settle, again, they're currently launching their platform with a number of European financial markets. It's worth looking at how they're solving that problem. They create sort of an easily accessible, easy to roll out system that can play in with a bank's legacy systems, but also enforce those kind of established standards around regulatory compliance, I think.
Thank you very much. And so in my sort of, opinion, I think, Sid, you guys are doing some of the most important work in the space, which is providing analytics on what these what are the relationships between the transactions taking place of the smart contracts. And I presume you guys have sort of learned a lot of what's happening in the public domain, in the permissionless domain. And we're seeing blockchain technologies being sort of distributed ledger technologies now being heavily adopted in the permission space. What's missing, or how can you provide analytics in the permission domain of actually between different banks or different intermediaries, identifying what's happening in terms of the smart contract ownership? What do you foresee in the permission space of how smart contracts are being exchanged between different parties?
Yeah, I mean, when you think of smart contracts, it's kind of, you think of it like an app, right? Like a web app, basically. And so in the permission space, it's pretty much like Google Analytics for smart contracts. So how are they being used? Not necessarily who's using them, because there's a certain set of parties who can even interact with them, but what functions are being called. So to draw a parallel, there's a mint, burn, functions for many token smart contracts. So how often are they being called? At what times of the day are they being called? By which addresses are they being called? Are they being called from bank X or bank Y? At what times of the day? So simple things like that can increase the transparency for all parties, especially within the permission space.
And given that a lot of these decision-making processes will be automated, how important is that to make sure the consortium is distributed and you can very clearly identify where that decision-making power lies? And how is that model different to a permissionless sort of environment?
Yeah, 100%. Yeah, the thing with permission, blockchains as a whole, something that I've been having trouble getting to grips with is there's a fine line. There's not that much difference between a cloud provider, like an Oracle or an AWS, and a permission blockchain. Maybe you just have a few more companies in the space who decide the kind of rules, right? And so it's leagues apart from a permissionless blockchain, where you're talking about a private members club in Mayfair versus Hyde Park, where anyone can go. So I mean, which would you rather? Obviously it's cool to be in the private members club, but obviously not everyone can fit, right? And so in terms of setting the rules, I mean, there's this dichotomy in the permissionless space as well. To draw an example, Coinbase, one of the biggest exchanges, they released a whole bunch of new crypto assets recently, and there's been uproar because people want them to kind of hold their hand and say, you can only buy Bitcoin and Litecoin and Ethereum, and not all these other quote-unquote shit coins, right? And it's a dichotomy where people want the rules to be set, but at the same time, it's kind of centralized, right?
Yeah, one short comment on that. I was listening to a debate with Gavin Wood, the co-founder of Ethereum, and Vlad Zamfir, one of the leading lights, and they were talking about governance on the blockchain, and there was this massive discussion about should we or shouldn't we allow state change. And I thought, these guys need to dial into a call centre in a bank on a Saturday morning and listen to the little old lady who's currently can't get money out of the hole in the wall. And we don't know whether it's her mistake or she's lost it or she's even lying. But somebody affects a state change so she can get money out of the hole in the wall. There is a need for customer advocacy in these things. Yeah, you know, banks enable people to buy houses, cars, put the children through education. They do other things. It's not just about. These building blocks are phenomenal. I distilled it once quite succinctly, which they said that being criticised, defending the banks. What is it you do? I said, well, for 328 years, we've been selling trust. Along comes a set of technology that enables us to do that in a much more intelligent, flexible, lower-cost way. That's a good thing. It's not a bad thing.